Well, that was easy. Alright, welcome back everybody. It's another great day in the Black Hills. Briggs behind the camera. We're heading out to Nemo, which we've been to before in some of these videos, or we've been in the area of Nemo. That's where, way back in the first videos, where Briggs and Morgan and I hiked down to Doty Spring and looked at the springs. That was just a few miles outside of Nemo. We're going to be going right into Nemo, or within a quarter mile of Nemo today, and I'm out again looking for samples for my SED Strat class, and we're going to be looking at and collecting some banded iron formations out here that are quite common in the Nemo area. There's one active mine out here in the BIF, the banded iron, that is taking out the iron and then they're selling it for industrial purposes, so not making steel, but for components for primarily cement, I believe. And so we're going to be in that area. It's really, really beautiful rock. It's a siliceous rock, but it's Precambrian, so it's been metamorphosed, and so it's layering of iron banded with silica rock or chert primarily, and so we'll get on that. And there's several other lithologies out here. There's marble right close. We might go walk up and look at the marble and some other things out here. So we're going to be playing around out here for the next couple hours. So thanks for joining us, and thanks for coming along, and let's go explore the BIF. Okay, so we are just outside of Nemo, and you can see right behind me, this is the Nemo Cemetery. So we're about a half mile from Nemo, and directly across the road from us, I'll try to get a picture of the video when we leave here, but there's an iron mine right over there. And then this side of the road, this little knob right ahead of us here has iron formation on it. So we're gonna walk up there and get on the iron, look at the properties of the iron, try to collect some nice samples that I can use in class. And we're gonna walk around a little bit up there and then go back up behind us up here to where there's some deposits of marble, and we'll look at some marble as well this morning while we're out. So come on. Okay, so this is a little exploration pit dug here. We're probably 8 feet below the surface, and it's just a little horseshoe dig out. And so the purpose of this is you go in and you take out some material and then you evaluate it for iron content. That's what they're looking for here. And of course, if you're going to use it as an ore, then it has to have a certain content of iron. And so these little pits, you know, might be all around here. Probably quite old, probably in the 1800s these were dug. So let's go see if we can find some rock in here. Well, there goes that. So this is really common of what this looks like. This particular stuff right here is more of a schist type of rock. So it's thinly bedded, and you can see the dark in it. And then the secondary color is kind of a rusty red, and it's because exposed to the elements, oxygen and water rusts iron, right? So you get rust on your truck and it's kind of reddish or yellowish. It's exactly what this is. So this is iron formation. This is a type of iron. It's not what I'm exactly looking for. This is more of the schist. I'm looking for the stuff that's the strong silica stuff. You can see the bedding in here, very, very thin. So it's just so this is all marine deposits. There, see that, how that fell apart? Just in these thin sheets. So these are all marine deposits. They are marine mud. And so it's muds. If a mud or a shale deposit is metamorphosed, it turns into a phyllite or a schist. This is more of the phyllite type, really fine grain. It's got real thin lamination, platiness in it. And when this was being deposited as a mud in the sea, then the age of this is Archean. So this is back, this is in the 2.5 to 2 billion year old rock here. And at that time, the oxygen atmosphere of the planet was being developed. And as the environment became more oxygen rich, it would change the redox conditions. And iron at that time was disseminated in seawater as a disseminated aqueous phase ion. And as soon as oxygen began to oxygenate the waters, then that changed the state of the iron, and the iron would grab on some of those iron molecules and precipitate out as an iron grain. And that happened, those iron grains would settle in the muds that were being deposited, what you see here behind me. And then when it was metamorphosed, you get this banded iron, or an iron-rich shale. And so that's what this is in here. This is really similar to the iron that's being mined across the road. It's in this more of this slaty type of material, but I know that there's tougher silica-rich, chert-rich banded iron around here further. I think it's further back behind us up the ridge. So let's move on up that way. So if you can see back over on the other side of the valley over there, there's kind of a scar halfway up that hill. That is the iron mine that's active over there. And that's the exact same unit that this is. This iron has a trend of this direction, and so we're right along that direction. So if you can see over there, it's about the same elevation we are, and that is the iron mine. Okay, so you know the compass works by magnetics, and so holding it, well, let me get up here just to make sure I don't have any interference. So when you're away from anything with iron, the needle turns north. So there's north right there. Okay, so if I approach this rock, if it has iron in it, it will draw my needle. Yeah, no effect there. Let me try down here. Nope, so no effect. When we get on the really iron-rich rock up here, the compass needle will just start spinning like it doesn't know what's going on. And that's an indicator of high iron content. So we'll find some of that up here. So here's another excavation. So you can see again these pits. The rock is getting harder. Okay, so here's more of what the banded iron looks like. You can see the bands in there, so you can definitely see the banding nature of this. This is still has a primarily a phylitic type of a texture, although the banding is getting much more pronounced in here. I'm not seeing a lot of chert yet. We'll try the compass on this and see if it is any different. Yeah, this here is deflecting the needle about 20 degrees when you get close to it, but it's just kind of moving over and staying there. It's not oscillating. On these deposits up ahead of us where we get into the really solid chert, the compass needle will go like this. It'll just be swinging back and forth over 40 or 50 or 60 degrees. But we're getting the first real hint of banding in here, for the which is where the banded iron gets its name. There's a nice piece. You can see that strong banding in there. The dark bands are the iron, and then the white is probably getting into the silica, the quartz, which is the going to be the chert. So let's hammer this and see if it breaks easy or it's soft. Okay, you hear that difference? Sounds like glass. Look at that. There's a fresh surface. So very strongly banded. All the dark bands are iron. And this is getting toward cherty layers in here. Let me take a look at my hand lens and see if we can see any detail. Yeah, it's all crystalline. The lighter layers are a fine. It almost looks like like the layers originally were thin layers of just quartz sand. So you might have some sand and then a layer of iron, some sand. So it looks like a sandstone texture. Of course, with it being metamorphosed, it'd be a quartzite with the banded iron in it. So I'm going to hang on to this. I'll take this one back. This will be good for class, and it'll be good to look at under the microscope as well. Okay, so I think we're getting on higher grade stuff, you know, right here at my feet. If Briggs can come in here a little closer. Again, you can see the good banding on this, and the bands of iron look to be getting a little thicker and heavier in here. There's a little pit in here. I'll work my way down. So this whole wall over here is banded iron, and you can see it's all red. This is, you know, this is all natural rust that's covered the surface, and so all that nice banding is hidden behind here because of the surface texture, or the surface erosion. So I'm going to try to break a piece off. Well, that was easy. Yeah, it's highly weathered. This piece in my pocket is about as good as I'm seeing in here. So let's see if it affects the compass. Should be a higher iron content. Okay, so my needle is pointing that way. Now it's pointing that way. That's not as bad. It's not as bad as I've seen in several places around here. I know some of the places up over the hill and down the ways, the deflection on the needle is much higher than this. Okay, well, that's another pit. Okay, so look at this boulder right here. Is a big boulder of quartz, and this is originally vein quartz from Precambrian rock. Over here, same type of thing. This is all Precambrian rock. This is Precambrian rock, and it's just boulders sitting out here on this kind of flat surface in here. So in actuality, we are standing on a terrace deposit, again from old rivers that would flow through here when the topography was way above where it is today. And these are the remnants of the channels. You can see they're quite coarse. They're up to 2 and 3 feet in diameter. And this whole little knob of hill that we've been walking across here right now immediately is an old terrace, and it sits on top of the Precambrian, which is the banded iron. So the banded iron continues all the way through here, but in this stretch of probably a couple of 100 yards, it's capped by, I think, probably close to 40 feet of old terrace gravels, boulders in this case. I think you guys are going to start thinking I'm lying to you because I keep telling you I can find these things, and then I come out and we can't find them. So that's kind of, I mean, I see no tree here with an outcrop at the base of the tree. And we've walked across this slope, and I'm pretty sure it's not up higher, because then we get into the terrace gravels. I'm going to make one more check down here. We've scoured this country enough over here, and I haven't been able to find that banded iron, the cherty stuff that really deflects the compass needle, but The good news is I have a good enough sample to use in class, and you've seen this area now, so I'm going to call it good and call it a success. We have a sample here, and so I think we're going to head back to the truck right now, and then we'll probably walk up real quick to that marble deposit and take a look at that marble real quick before we call this a video. So see you in a bit. So we're on a little excavation pit again. We're probably about half a mile from where we were in the Biff, and this is a deposit of marble, and marble is metamorphic limestone. Limestone is calcium carbonate, and when you metamorphose calcium carbonate, guess what you get? Calcium carbonate. The only difference is the carbonate grains recrystallize into much larger grains. So marble then is just a coarser grained calcium carbonate. It's still calcium, and you can see in here this white right here. These are calcite crystals. So let's break a piece of this off. Okay, so this is kind of a gray and white rock. Some of it in here is kind of bluish. Over the ridge, just down to the other side of us, somewhere in here, there's an abandoned old pit that this stuff was actually mined. So they might have been using it for, you know, try to get tombstones or something like that out of it. It scratches up relatively easy. There's Fizz. There we go. So this has got an extremely tight matrix in it, where it didn't fizz at all on a fresh broken surface, and I had to scratch quite vigorously for it to get to an area to where it would fizz. But you can see it's very hard and colored with the white and the dark gray. I don't see any of the blue stuff in here, but so this is marble. There's a few small marble deposits in the Black Hills, not a lot, but this is one of them. This is part of the Blue Draw group, and it's Proterozoic, I believe, so a couple of billion years old. Again, it's a marine deposit. Started out as a marine limestone, and then was metamorphosed into this marble, and has a zone here that continues for a couple of miles. And I think it's the only marble in the Black Hills. So I think we'll call this a video. We've got Biff. We've got some good samples of Biff for my class. I will take this marble back as well and use this in class in a couple of weeks when we talk about carbonates and we do some carbonate stuff. In fact, I'm going to break off probably a bigger piece and take with me. So thanks for watching. I'm glad you came along with this. Give it a thumbs up if you enjoy these videos. Share with your friends. Oh, and it is starting to snow. I think it's snow or sleet. Little frozen droplets. So we're ready to head out of here. See ya.